Hi guys, welcome to our video lecture on the waves and the shore. So we've talked about tides, we've talked about general ocean movement, we've talked about density, and we've talked about, thanks Tucker, it's okay though? Okay. Alright, so we've talked about density, we've talked about the waves, we've talked about freshwater. This is probably going to be one of our last lectures here, and then we're going to finish up with maybe a couple experiments and some review, and then you're going to take your test on Monday. So here we go on the waves and the shoreline. So waves, and you don't have to write any of this down, but waves are the ocean energy traveling along the boundary between the ocean and the atmosphere. The power of the waves is most noticeable near the shore, but it is happening all over in the ocean. We have some awesome definitions real quick, and if you're a surfer, this looks like quite a mighty wave. I don't know if I would want to be pummeled by something like this. It looks to be about 10 foot tall. That would hurt quite a bit if you were to crash. You wouldn't see anything like that, most likely, on the East Coast, though. That is a West Coast looking wave right there. We have some definitions when we are talking about waves. The first one is what we call a swell. It's a group of long rolling waves. We call this a swell. There are three things that affect the size of the wave: how fast the wind is moving, so the speed of the wind, how long of time the wind blows, and what we call a fetch, which is the distance between the wind blowing. All of those three things will either create smaller or larger waves depending on how we are changing those. So if the wind is going more quickly, we're going to see larger waves. If it's wind blowing for a longer amount of time, we'll see larger waves. And then as the further it blows, the longer of waves we are going to have. There are four-ish different parts of a wave. The crest is the highest point on the wave, and remember, we're going to zip through this pretty quickly, so if you need to pause me to get down your notes, you're more than welcome to. The crest is the highest point of the wave, and then the trough, there it is, I don't know. The trough, that still doesn't sound right. Trough, there it is. I just say hog trough to remember how to say the word. The trough is actually the lowest point of the wave, and the distance in between the crest and the trough is what we call wave height. It's a vertical distance. And then the wavelength is the distance between two corresponding points. Usually it'll be either the distance between two crests or two troughs. The average wavelength is about 3 to 2 times the wave's height. So there's a general relationship between wavelength and wave height, but that's not as important to know as just the general definitions there. Remember, trough is low, crest is high. Wavelength is the distance between 2 points of a wave, either 2 crests or 2 troughs. Waves break in the water that is as deep as 1/2 of the wavelength. So there's, if you didn't know, there is a science behind your waves breaking. And when we talk about waves breaking, we're talking about when they start getting those white caps, right? Where you would start surfing on them. You can't surf on a wave that is just a bump. You're not going to go anywhere. It's when they start to curl over and become white caps that we call them breaking. So there's a general idea that the waves are going to break when the water is about half as deep as the wavelength. So if you look right there, you can kind of see that. So the energy in the waves, so as a wave moves across the surface of the ocean, only the energy moves forward, not the water. So your water is not actually moving forward in the wave, it just looks like that. It's actually the energy that's moving forward. So that's a common misconception when we talk about waves. Breakers are the foamy mass of water that washes onto the shore. So the white caps that we're talking about. If the ocean floor is really, really steep, the waves are going to break with a really big force. If the ocean waves are not steep, the waves will spill forward in a rolling motion, less likely to knock you down, and a lot gentler. And we've also got some currents to talk about. So the definition of a longshore current, this is the movement of water that parallels the shore within the surf zone. It occurs when a wave approaches the beach at an angle, and these are actually going to form long sandbars. Okay. You've got a nice picture of that. So the longshore current is actually this right here, and it'll form sandbars as it erodes the material or weathers the sand and erodes it, moves it from one place to another. You've got a picture of those on your notes pretty nicely. There is a picture of said sandbar. You can find these out in the ocean though as well. We also have what we call refraction, which is when the waves approach the shore at an angle. They bend when they reach shallow water. This is called refraction. So if you were looking at a bird's eye view and you started to see this bending right here of waves, you can tell that this is shallower water. Refraction causes waves to hit the shore head on. And then we have three kind of ocean terms, well, two ocean terms right here to also talk about. We have the undertow and the rip current. So the undertow is generally a gentler current that moves water and sand from the beach back to the shore. Okay, so it's nice and gentle, nothing to really worry about. But a rip current is when the dangerous current that flows away from the beach carrying sand and water. So you look there on your picture right there up above. It's with a longshore current, so you can actually see those rip tides that are pulling that longshore current where two of them meet and then they pull out. They're actually really dangerous. In our previous lecture, we read a poem about rip tides. If you needed to escape a rip current, you would swim parallel to shore and then come back to land on a wave once you've escaped that rip current, because they're not everywhere in the ocean. It's just certain spaces, and you can actually see it if you look. Let's see. We had a picture. I don't know where I went. You can kind of see it right here in this picture. Can you see how right in this region it looks a little bit darker? That's actually the longshore currents are flowing towards each other, and when they hit, they pull each other out into the ocean, and that's actually the rip right there. So that's pretty dangerous. You can see it here. Kind of, it starts to pull each other. I've only ever been caught in a real bad rip current once. Usually, if you're a pretty good swimmer, you can get out of them, but not always. So it doesn't. Sometimes they're just really bad, and you get caught in it. I got caught in one this winter trying to surf, and it was really cold. So I had my wetsuit on, and it was cold, so my arms and legs were kind of numb because it was so cold. And I didn't realize what was happening at first. I was just paddling on the surfboard, and then I started to realize that I wasn't going anywhere. I started to freak out just a little bit, but eventually got a hold of it and made it back. But it was pretty scary, and it really made me realize that maybe I shouldn't be surfing in the winter alone. But anyways, it is possible to escape a rip current, though if you are not a good swimmer, you should really pay attention to when they are bad. They're signaled by a red flag on a lifeguard stand. There again is your picture. And our definition of a rip current is forms when water from large breakers return to the ocean through channels and underwater sandbars. See the sandbar right there? You can see it right there as well. And there again is your red warning sign. And that is the end of our notes. Okay. Have a great day, guys. I hope you enjoyed learning a little bit more about waves and the shore. Goodbye.